reinforcement pattern, how to reinforce the foundation soil. This is the ideal reinforcement pattern. You can see normally it is curved because the direction, the alignment of the reinforcement should be in the direction of principal tensile strength. Tensile strength. So principal tensile strength direction is that way. So we should install in that way. But practical difficulty is there. So always we do this practical. This is our practical reinforcement pattern, horizontal layers, and we based on our experience, how many layers, what should be the spacing, those things are known to us, and these are the mechanism. I am not going to share much, but how that benefits, whatever benefits I am talking in terms of load bearing capacity and settlement reduction, they are coming through these mechanisms: shear stress reduction effect, confinement effect, membrane effect. We have anchoring effect, particularly when we are using the geogrid to reinforce the foundation, and we can group like that reinforcement function, different mechanisms, and even sometimes there is a separation between our soft foundation soil and granular layer. We are still getting benefit just because of separation. We are separating the two layers. And there is a research that under what condition as a designer we can consider separation is the primary or reinforcement is the primary. Now these are the design parameters. You can see the depth of the embedment depth is D, and first layer should be below U, and that is typically 0.25 to 0.35 B, and a spacing you can see H, a small h, that is again 0.2 B to 0.4 B. In a similar way, we know the B can be even 3B to 6B in some cases, and the maximum depth of reinforcement, a small d, can be, let us say, B to 1.5 B. So we need to understand that it is site specific based selection, and ideally we should try to consider these parameters as a initial design, and these days we have even numerical software to estimate our load bearing capacity and settlement, and then we can go ahead. And always we explain bearing capacity ratio, reinforced to unreinforced capacity, that is called bearing capacity ratio. And you can see here that we have better improvement, means reinforced soil. For a given settlement we have increased load bearing capacity. So I talked about that practical reinforcement, horizontal layers, we don't have a space, and also to utilize the maximum benefit, I had used in one of the consultancy projects initially. So what I am saying that we can have wraparound ends the way you see here. So we are saving the land also, and moreover it is effectiveness for the same material, So we have also developed mathematical expressions for calculating the bearing capacity, the way we see the Terjadi bearing capacity equation. Here the explanation is a mechanism, how we are getting a kind of confinement, right? And there is a passive resistance that provides the technical advantage for us. So comparison here side by side, just horizontal layer without wraparound ends, with wraparound ends, and finally I will say that this is the conclusion part, although I have more slides, but let me summarize here that we are getting additional improvement to the load bearing capacity, additional improvement to the stiffness in terms of the modulus of subgrade reaction, reduction in width of land required for the construction of foundation. And this technique really very much useful, particularly in our urban areas or even in hilly terrains, because we don't have land there also sometimes if you want to strengthen our foundation. So we have done model footing in our lab. So some of the PhD students, as you see the results, no need to go more analysis here, and those who are interested, they can read the articles published. You know that most of the research studies are basically on dry sand, but we have been able to do in submerged condition. challenges are there. One trial, next trial you can understand how research is submerged condition, largest mostly submerged condition, but we researchers, have limited whatever, facilities or avoid problems. So in future, I am expecting that most of our research must be on real life situation conditions. Then results are more. You can see just when water table rises, there is sudden settlement as well here. So these are the results. I am not going to discuss because we have to numerical modeling also we have done to demonstrate. And you can see we have used the pressure cell also to measure how the stress is being transferred in case of unreinforced, reinforced, without wraparound ends, with full wraparound. And finally, you can see here three curves are there. The one curve full wrapped, so material remains same. Better to have a full wrap, not like just horizontal layer without any wraparound. So advantages are there. Our research has demonstrated experimentally and numerically, and this technique is now being researched by others as well. So as you can see the title, the way I started develop this technique in 2007 and 2008. So researchers are further doing more advancement in this. So this is not our work. As you can see the reference coming from different team of researchers, and they have also done, and they are also saying that yes, this technique is more effective, and in place of this polymer based, synthetic polymer based geosynthetic, we can go for our natural based materials, depending on what kind of requirements are there. Sometimes you need for 1 year, 2 year, 3 years in some projects, because ground is going to settle and it will have better strength later. So we don't need in the long term that kind of. So, and this is a field project. You can see in Canada, there is a case study, full case study, how they have avoided defoundation. So they avoided defoundation just by reinforcing the foundation using geogrid, and in harbor, coastal area, so harbor. And this is the finished product, completed tanks. And our development has been also appreciated by Indian Geotechnical Society, because we published one research article, and globally also. So I have reported in my textbooks. Globally also, it has been appreciated whatever we are doing in this area, particularly foundation. And always I say that this conference is not just presenting papers. We all have now a global team. Okay, in years to come, we will be collaborating. As you have seen in the morning that how biology, biochemistry, right? Mineralogy, all areas, right? We need to, because we don't have full understanding. We have been educated, but fundamentally we know, but we have to go deeper and deeper. And at the end of the day, whatever we do complex, it is very important that we have to give a simple way of doing things. Otherwise, it will remain with researchers. This is very, very important for us. And this is, I always say that learning is a life journey. We have always weaknesses with us. Okay, and those who are sitting here, young minds, this conference is more for them. You have to take many things from this presentation, and this photographic views, as you see when I was at IIT BHU, I am always using this. So I think thank you for. Okay, any question? Otherwise, a standard answer during the break. And this WhatsApp is also available, so we can always interact. That's why I share my mobile number. Okay, so anytime you can interact with me for any question, clarification, and doing more things in future.
Thank you so much, sir, for providing us with an insightful introduction to the topic of shallow foundations with geosynthetics. Your detailed explanation
A very good afternoon to diverse gathering in presence of Honorable Professor Bhattacharya, Professor Das, Professor Sukla, Professor Piju sir, Professor R.P. Singh sir, and other dignitaries. It's an honor on behalf of RISCE 2024 to present a vote of thanks in front of you to the Professor Sukla. As our anchor said, he does not need any introduction. And दियो को लाइट सूरज को दीप जलाने जैसा है इनको इनके बारे में कुछ कहना. But it is an honor and opportunity to present a vote of thanks. I would admire and I would like to a valuable time and his dedicated effort he has spared to us, and he has enlightened with his knowledge and his vast experience. He has covered various aspects on cello foundation, uh, like geosynthetic materials and various practices used for the sustainable development. I'm sure it would have been a beneficial session for all of us, and participants across the globe attending this conference would have been a great takeaway, and they would have gained great knowledge. I am also thankful to him for continuous guidance and support and mentorship provided ever since the inception of the idea of the conference. I hope he will extend his kind support in upcoming years and upcoming time as well. I am very much thankful to Sir for sparing his valuable time. Thank you to all. Also, I request our